Hello, everybody. Thanks for joining our mcube 5.3 launch. Please use the chat function if you have any questions. We will answer as many as possible towards the end of the webinar, and we'll get back on the ones we didn't cover offline. I don't know how you feel, but to me, it seems agents and agentic AI are everywhere. In my discussions with customers, partners, and colleagues, even in the news. Strategically, TCG Digital has engaged in this conversation through multiple events around the globe. For example, in Berkeley, California, and New Delhi, India. Dr. Chatterjee, our group chairman, and Debda Sen, our CEO, have emphasized the importance of the infrastructure for intelligence at scale. In line with this strategy, we have focused our R&D investments for this release on agentic AI and the underlying lakehouse infrastructure. Those will be the two main topics featured in our webinar. We will do this with the help of our distinguished panelists, Ashutosh Ranjan, who leads our global AI data science team, and Devjyoti Gupta, our Chief Technology Officer. So now, to get us started, let's kick off with the keynote by our CEO, Debda Sen.
Hello, and welcome to the launch of version 5.3 of mcube. For the next 1 hour, I invite you to sit back, relax, and listen to the exhilarating journey of this version that we have brought for you. The team has been working tirelessly over the last 5 or 6 months to bring this version of mcube, which is the best ever, the fastest ever, and I'm sure you will absolutely like it. We launched the agentic framework in version 5.2. We have now made it much easier for you to create agents through our agent builder. And we also have the MCP framework now integrated in mcube to be able to access all the enterprise information that you have, which would work with the LLMs and create agents quickly. We have the ability to create a private LLM so that your enterprise data remains within the enterprise, which would interact with the public LLM, whether it's ChatGPT or Claude or Gemini or any of the others, and then have the agents talk to each other, have the agents reason amongst each other, thousands of them, and come to a decision just for you. The icing on the cake is the semantic layer, the semantic knowledge graph, which we also launched in version 5.2, and now it's significantly enhanced to be able to reduce hallucinations, to be able to make information more contextual from a business perspective, and get the answers to you very, very quickly. Talking about quickly, creating business impact is our mantra. We say velocity to value. The return on investments of your data and AI project has always been our focus, and it's done much better with the version 5.3 that you're going to see. It continues to have a very strong data integration capability. Another feature that we had launched in 5.2, our new data integration module, it's made much better right now, corroborated with probably the largest set of functions and libraries from a machine learning standpoint, and now integrated with the agentic framework and the semantic framework for you to get quick business impact ever than before. So sit back and enjoy the next 1 hour and learn about what mcube 5.3 is. And I request our Chief Product Officer, Andy Diggleman, to tell you a little more about it.
Amazing insights from around the globe, providing business context to our daily life as engineers who drive mcube forward. Here are the new features of mcube 5.3 at a glance. Most importantly, as mentioned before, agentic AI and data lakehouse, which we will cover in depth in a minute. In addition, we have broadened our support for Oracle Cloud with integration for MySQL HeatWave and Oracle Autonomous. We added many new features to our low-code development environment, Easy Extend, and our BI dashboarding module, mostly driven by real-world feedback from the field. Shortened time to value for mcube-based applications, agentic or AI-driven, is a top priority for us. On the operations side, we have strengthened observability with a unified log view, added usage analytics, and delivered a common notifications framework that is leveraged by all mcube modules and can be used by any application built on mcube. Now, on to our first main topic. Before we dive into further discussion, Ashutosh, please show us a live example of an agentic application.
Thank you, Andy. So I will quickly bring up my screen. Hello, everyone. So let's look at the example of a semi-autonomous agentic AI workflow. And when I say semi-autonomous agentic AI workflow, it means that here we are doing some R&D in the field of petrochemical with human in the loop. So let me first establish the use case. The use case is to accelerate the R&D time and discovery of catalyst in hydrocracker plants. So when we talk about hydrocracker catalyst, there are multiple factors which impact the life cycle of a catalyst in hydrocracker, namely selectivity, activity, and cost. So now we have to discover and we have to design a catalyst which has good blend of selectivity, activity, and it is also affordable and cheaper in nature. So on this screen, you can see that we have the option to select the maximum. So which particular product I want to maximize, what is the range that I want to keep in selectivity. Also, what is the activity that I want? So what is the life cycle of catalyst and the life of the catalyst, how much do we want it? And also I can give the weightage to cost. So here I have chosen 25% weightage to cost, 25% to selectivity, and 50% to selectivity activity, which means we want a catalyst which can perform for a longer duration of time. Now I just have to click on generate hypothesis. What this agent is doing in the back end, it is doing some design of experiments. So by the time the result will come up, I will quickly explain you what is happening at the hindsight. So this design of experiment agent is communicating actively with LLM agent, and LLM is already fine-tuned on lots of catalyst data. So we also call it Kata LLM. So when the DOE generates the different permutation and combination and scenario, the Kata LLM agent actually does the virtual screening, as we call it in drug discovery, right? So during virtual screening, we remove lots of scenario which is either infeasible or it is not affordable in nature. Then there is the third agent, which also brings in lots of contextual information, and it is semantic agent. And on top of it, we are also using certain AI agent to predict the selectivity and activity of catalyst based on the pattern we have seen from the laboratory analysis data from the past. So now we have got some of the hypotheses from our agents. Let's look at them. So here you can see that these are the combination that our agent think are good to go ahead and test in the lab. We also have the option to create our own hypothesis. So we can, and as I said, that this is a human in the loop system. This is not a fully autonomous system. So here user can also generate their own hypothesis and they can test their hypothesis side by side against the AI hypothesis. And then you can run the evaluation metrics and you can see that what is the different predicted selectivity, activity, and cost score for different combination and hypotheses that AI has generated. And after making sure that everything seems good, then only I will click on send to lab and it will be sent to the lab. Finally, the result will come from the lab. So let me go back to the previous screen. And you will be able to see the result. So here I will actually choose the previous, some of the previous hypotheses which has been all generated in the past, because the current one is very new and there won't be any lab result for those. So let me quickly search for the historical ones. Here we go. So this is how the lab result looks like. And again, I have the option to either accept or reject the result. So in a deep R&D setup, this is how we can see that semi-autonomous agentic AI system can help us accelerate the time, at the same time not giving all the levers to the machine and keeping human in the loop. So now let's look at our Kata LLM playground, where you will see that researchers and scientists, they can ask the questions directly in the form of their chat to see the reasoning behind different actions that your LLM and agentic AI system is taking. So if let's ask a simple question, would you increase the crystalline silicon and aluminum content to 35% in the catalyst lead to higher selectivity for gasoline? Now let's see how the result will come up. And user can ask these questions and get the either like a very short answer or a detailed answer. So here the LLM has decided to give a very short answer. Now I can also ask them to do the detailed analysis. And here you will see that it will do a detailed analysis of PTZN and catalyst and give me the result. So this is another touch point where user can interact with the system and understand the working behind and thinking behind the Kata LLM altogether. So now we see that there is a detailed answer that we are getting for this particular question. So thank you, and over to you, Andy.
I said, wow, looks like a lot more work can be delegated to agents in such an agentic application. We move from applications that simply support us to do work to applications which can actually delegate work to. How would this have looked like without agentic technology at hand, Ashutosh? How would that have looked like without all these agents running in the background?
Yeah, so without agent, I would say, let's first take a step back and understand why agent is very important. So agent brings the autonomy to the system. So it has the capability to take decisions, do iterations and reasoning, and iteration based on reasoning basically, and then take actions. So if we remove agent from the system that we have just seen, we will see that we will still have the AI models that I talked about, which will extract the pattern from the historical data. We will still have the standalone DOE, design of experiment system, which we are using historically forever, right? In any drug discovery or catalyst discovery use case. But the unique blend of iteration and reasoning that LLM is bringing in, and agent is bringing in, which can help interact and have the interactivity within multiple systems, be it DOE. So DOE is generating the permutation and combination of different materials. At the same time, agent is virtually screening those combinations for its feasibility and cost effectiveness. The next one is the AI model, which is again coming together and predicting on the same combination that DOE has generated. So here you can see that everything is now integrated, which would not have been the case. And even if you can make it interactive, it will be rigid and it will not do reasoning among themselves and take the decision on its own.
So if I'd like to summarize that is, thanks to all this automation and the agentic behavior of the processes in the background, we don't need a project plan where we have the specialist for design of experiments coming up with a proposal, which we review and then said, okay, that's the way we want to move forward. And then take the results, at the same time, have a project for a data scientist who looks at patterns and tries to figure out how he can predict failures or something like that. And then in the end, having to put all this back together then. All of that is happening in a circle of agents talking to each other. Now, we have seen this for how to accelerate R&D. Can we switch gears and look at a completely different industry and maybe a use case which directly impacts end consumers?
Yeah, thank you, Andy. So I will quickly again bring up my screen and show a demo from another domain, which is insurance. So I will quickly show how an automated, fully automated in this case, and fully autonomous agentic system for claims automation looks like. And here, when I say claims automation, it's just not the automation, but it's also a blend of automation and AI models which are working to detect fraud and analyze the claims, etc. Okay, so let's now deep dive into our demo. I will go to our AI application, AI Workbench, and open the project for claims, car insurance claims automation. Here in the project page, you can see various options. We have project name, we have description. So it says that this insurance claim processing system is an AI-powered solution that automate claims validation, estimation, and processing through intelligent data retrieval and agent-based workflow. Then comes the explainability rules, which clearly says that models should be transparent and give a clear reasoning for the decision, and the success criteria is 80% recall and 95% precision. So now let's go to the workflow and see the workflow, how it looks like. It has only 2 nodes, pretty neat, right? So now let's let me run the node and go to the chat node directly, and I will ask a question to this chat node. So we see that now assistant is thinking and typing. It has also brought in some of the information related to the claim, but it will take some time because agent will be analyzing lots of data in the backend. By the time this analysis is happening, let me show you the structure of our agentic workflow. So let's go to the agentic AI node, and this is actually a sub workflow. We'll go to the configure node, and here you see everything happening in the backend. So let me quickly start with the first node. So we have a start and a stop node, which marks the start and end of our agentic workflow. And then we have LLM node. Our LLM node can connect to either either enterprise LLMs, which are hosted by OpenAI or Google, or we can also connect to self-hosted LLMs, which will ensure complete data security, right? Then we can tune the parameter like temperature, we can write the system prompt, and we can turn this LLM very much into a small agent in itself. Now, how the agents communicate. So if you have any agent working outside, so we have created some of the agent to analyze the data, some of the multi-model agent to look at the car damage images, look at your driving license, correlate all the informations together and see whether your number plate, driving license, and car images are matching or not, what is the extent of damage in the car, etc. So here, using our A2A client node, we can connect any external A2A server, and we can utilize all the agents hosted in that server. So we have daily claim handler, we have claim document processor, we have then insurance plan. So then we are also bringing in all the policy related information and all the terms and conditions of the policy. So here you can clearly see that we are juggling between lots of structured data and lots of unstructured data at the same time. The benefit of agentic system is all these agents can communicate with each other with A2A. It can also call MCP, which is Model Context Protocol tools, which is hosted anywhere in the world. So you just have to integrate and connect it to MCP tool. You can also create MCP tool within the system. And finally, we have a summarizer agent, which will take all the information from every agent which is working continuously and bring all the information together. So now let's get back to our chat application. So I will close this sub workflow and I will move to the chat interface. Now, this is the result. Let's look at the key findings. So it says that there is a claimant, this is the vehicle, and the damage is at the right quarter panel dented, claim was approved. Then there are some notable inconsistencies that has been found. So it says that the document one shows a Jaguar with license plate this conflicting with Mazda vehicle in other document. This may be unrelated or misfiled. Similarly, so what it shows is that the agent is able to get to multiple documents at one go, your policy document, your license plate, your driving license, all at the same time, and it is able to correlate the information coming out of all these different type of data sources. And finally, it is saying that there are some inconsistencies for which you may have to put some additional check. And all this information that you see on the top is for the surveyor who is using this system. Currently, this system is a dev environment. So when we go to the actual end user screen, which is for surveyor or assessor, you will not see all these dev workbench options, and you will just see the chatbot assistant over there. But now let's look at the report that has been generated for the end customer, the policy holder itself. And this is where again generative AI can help you leaps and bounds by helping you synthesize the new information in a particular template. So after the agent has thought through in the entire scenario, it has given some of the action points for assessor or surveyor, and then it has also generated the customer or policy holder report, which you can see here. And this is a comprehensive report which can directly be sent to the customer in a PDF file or in a email or even through the app. So now this was just about one claim where it says that these are the things that we need to do, what happens next. This is for the policy holder. Payment will be processed within 5 business days. You will receive the confirmation via emails, etc. Now, the next information that we can analyze with this system is we can actually analyze the information for and all the claims submitted for a particular day, which is today. Okay. So now the next question that I have asked the agent is to process all the claims that are submitted today, which is 24th of September. And now we can see that so far there are 2 claims that has been submitted, and these are the information for those 2 claims, and this is how the information looks like. So this agentic system can not only help you analyze one claim at a time, but it can also do it in a batch mode, where at the end of the day, surveyor can just come back and say that, okay, analyze all the claims for today. And that's how it is going to be very helpful, either in batch mode or in a live mode where you get one claim and you want to process it then and there. So thank you, Andy.
Having seen all the power of agentic applications, I also recently stumbled over an interesting reading. The statement goes as follows. Thanks to agentic applications, we have elevated the saying garbage in, garbage out to garbage in, catastrophe out. Or in other words, the role of data, data quality, and data context has become even more important in this agentic world, where we actually delegate processes and actions to machines. So DG, how do we ramp up our data environments to live up to the requirements of trustworthy agentic applications?
So, of course, we are actually bringing in the lakehouse construct as a storage. And just to highlight like how the lakehouse has come about, So I would ask you to look at this schematic, and it highlights how the lakehouse construct has come about. And just to illustrate exactly the point which you stated, Andy, how does quality, the demands for the data quality and integrity of the data start making itself felt. So in the beginning, we were very much used to be using the data warehouse, and it was very, very good for analytics and business intelligence and reporting. And in fact, that was the primary use it was put to. It works with structured data, and you could get your business insights very nicely out of that. But in came AI, and this AI started needing a lot of raw data, the raw data from a lot of feeds, which could be, audio, video, it could be unstructured data brought in by the crawlers. And somehow when such a volume of raw data started coming along, the data warehouse constructs actually was short of serving the need. And that is when we evolved to the centerpiece of the middle picture out here, which is the data lake. And the data lake was a very good construct to get along with. That you could have all your unstructured data, the big data come in there, and you could extract some bits of it into a data warehouse and serve your analytics and reporting needs as you did earlier. And this was the era of when you did, this batch AI. You ran predictor models, and you could predict and you could take these recommendations and incorporate them into your decisions. But now you are moving into the era of the real-time decision enablement, decision automation, and even autonomous agents making decisions for you. And here, this problem started coming up with a lake, because the data lake was actually, the saying goes, the data lakes were very prone to turning into data swamps, because into that huge data lake, there can be a huge variety of content, various kinds of files and data, and the system was very soon losing track of what is where. And that leads on to the famous statement that you just recently read: data garbage in and catastrophe out. So we needed a solution for that, and that brings us into the lakehouse construct, which is the rightmost figure in this depiction. So what the lakehouse construct does is it brings out the best of the data lake and the data warehouse. So the incoming raw data gets stored as it used to be done in a data lake, but on top of that, there is a very robust metadata layer, which actually identifies what that data is. And out of this metadata layer, then what you can achieve is you can get your structured warehouse like behavior to serve your reporting and analytics and BI requirements. And you can also have your agents and AI work very seamlessly, being well guided by the metadata layer, and diminishing your risk of going into catastrophe so often. And that is the lakehouse construct. And the lakehouse construct we have brought in 5.3 is the Delta Lake. And we can I think that is your guarantee that the data which the agents feed off is reliable, it's cataloged, is very, very systematically arranged.
That sounds like we are actually at least getting a handle on the number of catastrophes which we might generate by by challenges with data. If you look at this a little bit further, DG, in a nutshell, right, what are the key features of the lakehouse that makes most of the difference to what we have been used to up to today?
So I think we can bring up the next slide. So here we see the more important ones which the lakehouse affords us. And this is primarily the ACID transaction capability. And just to give a context, so if you were using a data lake kind of a store, an object store, you will not be able to achieve this ACID capability. And the ACID is an acronym for atomic, consistent, isolated, and durable. So this is exactly how data needs to be written in a ledger. So you cannot have a duplicacy of a transaction. You should have one single instance present, and it should be actually indisputable. It should be atomic, disconnected with the other instances. And what this lakehouse provides is the ACID compatibility, and this is basic key feature why that the lakehouse can serve as your transaction stores as well. So that is why it brings their credibility for supporting the business intelligence reporting and analytics. The first one. The second one is scalable. So the scalability of data and metadata. And this is the lakehouse, in fact, uses one of the cheapest stores, the storage, the disk storage systems, namely the object store as a base where the data is written to the disk. And it is the metadata layer which actually makes that kind of data persistence absolutely reliable. And using the cheapest store and the scalability afforded by the metadata, so the lakehouse is unbounded. You can absolutely grow to petabyte scale lakehouses, and with the same amount of reliability. And you can rest assured that your disk costs, either on ground or in the cloud, are not going to punch a huge hole into your pocket. So that is the second part of it. The third part is an interesting feature. This is the time travel. So in a ledger or a record, what you have, even if it is ACID, it's the last instance or the last instance of truth which is reflected. But here in the lakehouse, the metadata layer captures every minute delta changes to the record. So that allows you to roll back in time. And for instance, if you had a bad data feed into the lakehouse, you could roll back. You could just roll back and get to a state of the data, to the previous stable state of the data. And it allows you to do the time travel. The schema enforcement and evolution. So the schema enforcement, Andy, that with a structured relational schema, you cannot just write different fields into one field into another field. So, but when you come to a data lake kind of a thing, since the storage is with objects and files, you can very easily swap around. The lakehouse construct and the metadata, it is a guardrail against such mishaps happening. So your records that get written, there is absolutely no chance of fields being swapped. At the same time, your schema can evolve, and typically the relational databases allow us an alter schema, alter table context, or a concept like that. It's absolutely the same concept that allows to this lakehouse construct as well. So you have the best of both worlds again. And the final thing with the lakehouse is, like, it can handle feeds, unified and batch streaming capabilities. So while on one hand you are streaming in video feeds from certain sources into your lakehouse, the other real-time feeds can be with structured data, can be individual transactions, or whatever kind of IoT feeds. So all of them can be handled in a unified fashion through a similar kind of an interface, and it can be handled at the same time. So that makes this lakehouse store almost, let's say, the best thing that could happen, given the demands on the data integrity and the quality brought about by the agentic evolution that we have been talking about for in the past few minutes.
So basically, we strengthen the basement to support even higher and higher and more stories of the building, with agents sitting on top of it, using data in a historic fashion, using data in real time, drawing decisions, hand over a piece of information derived from that to the next agent, who then will maybe talk to you and make a proposal of a next step. So given we have secured basically our the platform we stand on from a data perspective, let's put our mcube hat on for a moment. And I'd like to ask you, on behalf of our clients, what is the significance of the integrated offering of mcube? So we have the foundation that we talked about, and now we have modules on top of it, like Morphex for data management, Semantics for managing knowledge graphs and ontologies, and last but not least, AI 2.0, our AI workbench, which we have seen live from Ashutosh. So what's the significance of combining all those?
Can you get to the next slide? Yeah, this schematic actually answers your question. And first of all, I am absolutely in line with you for your analogy that if you want to have a very sound penthouse in a building, and you should have a very strong proper foundation. And in this case, the foundation is the data, and the penthouse is actually the AI and the agentic layers that mcube offers. And how the lake house, in this particular case, we are using Delta Lake as our lake house construct. It talks with the other components is depicted in this diagram. So as you very rightly say, that we have the ingestion, the data pipelines, the ingestion component, which is the Morphex. We have the semantic contextualization and the semantic metadata layer, which is the semantics, and we have the AI layer. So there is a very common interface that we use when the AI or even the ingestion talks to the data lake, and which is Apache Spark, absolutely scalable in memory and clustered compute, and very fast for data access and processing. And this on the semantics actually gives the contextual explanation to that metadata, and that is absolutely seamlessly integrated with the new data lake lake house construct, which is the Delta Lake construct. And overall, the modular approach of the everything gives, it actually lends quite a big amount of flexibility. So if I would just go further on that same point, what I mean by this flexibility is that if a customer would have had investment in other licensed data stores, namely Oracle, Autonomous, or even for that Azure SQL, Azure OneLake kind of a thing, mcube allows the other components can seamlessly work with these. And while all these components of mcube can be on-premise and can be on cloud, and when they're on cloud, they are cloud agnostic. So the whole thing gives the maximum amount of choice to the customer, I should say.
Thank you so much, DG. I think that was a very comprehensive answer, and it's great to see that with all this drive to more and more agents and the need for contextualization of information, so the agents can actually work in context, as we have seen from Ashutosh, insurance context or or R&D context, etc., etc. I think this opens perspectives of applications which we haven't even dreamed of yet. So I think it's time to get really creative in terms of looking at the possibilities of agentic AI for all of us and our organizations. Our webinar so far has generated quite a series of questions, and I'd like to choose a few of us to answer, and we'll throw them to our panelists or answer them myself, depending on how I feel about that. That's the great thing. If you are the moderator, you can actually choose. Question number one, quote, we have deployed a number of AI use cases in our company. Now, how do we identify a good use case for agentic applications? I think that one should go to Ashutosh.
Thank you, Andy. So yeah, as we have discussed in detail, like the difference between AI and agentic AI, and how do we gradually, how the world is gradually moving from an AI workflow to an agentic AI workflow. So this is a very relevant question in our day-to-day use case. So agentic AI systems are driven by three factors. One is the purpose, second is the reasoning, and third is the automation or autonomy. So now purpose and autonomy and reasoning are the two main things which is actually missing in the AI workflow. So wherever you think that the reasoning can play a role, and you can remove a human who is taking simple decisions from that loop and put that human to do some bigger task, basically, instead of just doing mundane tasks, the agents can help a lot. In R&D setup, where the human brain is the main source of any R&D, that's where the semi-autonomous agentic system will come up, like I have shown in the demo. So to gradually move from AI to agentic AI, the first step is the design thinking workshop. So you can start thinking and finding the use case where agent can help. We can also help you with that. And once you have found the use case, the process is very simple. TCG mcube gives you the option to create the agent and agentic workflow seamlessly and very fast. So the turnaround is very fast, and you can do the prototyping and show the value to the end user or business user, and then you can move to production.
Thank you, Ashutosh. I think the next question that I would like to take, because it's very close to my heart, is the following. I'm getting a bit overwhelmed. Agents want to talk to me on the web. I hear there are agents on my mobile phone now, and here I have seen agentic applications. What is the difference between an agent and an agentic application? I'd like to take this one for myself, as I said, because often I get asked about AI agents or agentic AI. Both AI agents and agentic AI are changing the world in different ways. While AI agents are great for automating repetitive tasks and handling specific actions, like question-answer systems, things like that, agentic AI is pushing the boundaries of what AI can do by making decisions, learning from experiences, and solving complex problems, all together in an agentic framework. So to do so, agentic AI is often orchestrating multiple agents to automate solutions for complex business problems. So it lends itself for more complex problems with more different process steps involved, while agents usually are just for a simple interaction to help me out with something. Next question, we still have some time. Let me take this one, quote, Agentic AI systems becoming more autonomous is a kind of a frightening proposition. How do you ensure reliability, guardrails, and governance? Taking my power as the moderator, I would like to hand this one over to Debjyoti, please.
So obviously, there are guardrails by which the agents can work. And here, the basic guardrail comes from the semantic, the ontology or the semantic layer. And here you can have the rules actually embedded, which provide the boundaries to the decisions which the agents can make. And it's when coding these agents and training them and actually binding them into that agentic workflow, one of the important steps is to look up these guardrails, which is available in that contextual ontology layer. And this is the kinetic and the dynamic part of the ontology that we are talking about. And without them, of course, the thing could go out of whack, if you would like to call it that way. But the right boundaries and the guardrails in place and encoded and structured, modeled into the semantics, what we call the semantic layer, that would be a very, very good insurance for agents misbehaving, if you are afraid of that.
Thank you, DG. I know this is a topic which we have been discussing amongst ourselves a lot, and we are very proud of the fact that we are able to really combine probabilistic, deterministic, and a knowledge graph-based contextualization, which helps us to keep things in check. We are running out of time, so all that's left for me is to say I really hope you enjoyed our event. I think here is why mcube 5.3 matters to you. You can shape working agents and agentic applications that make accurate decisions and provide grounded answers faster. That data it needs can be managed reliably and stored in a unified framework for all data types. People in charge of operations of these types of applications have more transparency and can solve problems much faster now. In short, mcube 5.3 moves from delivering powerful tools to delivering intelligent and sometimes even opinionated outcomes with governance and scale built in. To stay up to date with all things agentic AI and mcube, sign up for the Pulse of mcube, our monthly newsletter. Thanks a lot for your attention and participation. I hope to see you soon, virtually or physically. Let's join up and pave the way to adding value to our customers and our organizations. Let's boost our new, completely virtual and digital workforce together. See you soon, and thanks again.